Here you see, so how many components are present in the screw jack? You see, this is the body of the screw jack. So second one is nut. Okay. So screw spindle. This is the screw spindle. Third one. This is the nut. Second one. So which will come on top of the body. Okay. Screw spindle. This one, where you are going to fix the Tommy bar and you will rotate. Here you will be having threads. Okay. Here also, if you rotate this, so it will lift the this part. Okay. So this is cup. Fourth part is cup. This is cup. It will come above this screw spindle, and then washer. You will be having fifth part washer. Okay, this one. So then sixth one is screw. Okay, CSK screw. Then Tommy bar. You have seven component here. So you see the component. So if you see the old video as I shown, so all the components is having circular shape, isn't it? See, if you want to create a hollow circular object or circular profile, if you cut this, okay, so you can see you will get a profile or a cross section. So that will be circular in type. Okay, so if you create a circle, a cross section or a profile, that will revolve around the axis. So it, yeah, this type of component will do with the help of revolve protrusion. See all the components, this one also, this one also, all the components is have axis symmetry, isn't it? It is symmetric about the axis in all 360-degree direction. If that is the case, you are going to use revolve protrusion command. Is it clear? Are you understanding? Is it clear?
Sir.
ಅರ್ಥ
Sir.
ಆಗ್ತಿದೆಯೇನ್ರೋ?
Yes, sir.
Sir.
Okay. So here you see every component of the screw jack you have axis symmetry. Okay. So it is symmetric about the axis in all 360-degree direction. So this main body, nut, this is spindle and cap, plumb, this Tommy bar, this washer, what you will see, everything is symmetric about axis. So most of the almost all the component of screw jack is made with the use of revolve protrusion command. Is it clear?
Yes, sir.
Okay. So shall we start the drawing then? See, this is what you have to prepare. So actual section you have to prepare. Only this profile you have to prepare. And with the use of revolve protrusion, if you rotate, you will get a component. Everything, only this attribute portion you have to create. Here also this attribute portion you have to create. Here also you have to create only outer boundary. Outer boundary you have to create. So every component here also attribute portion you have to create. Okay, every component will have axis symmetry in a 360-degree direction. So we have to use which command? Normal protrusion or revolve protrusion? Which command you have to use? If the part is having axis symmetry, so then you have to use revolve protrusion. Is it clear?
Yes, sir.
Okay. See here, you see the component. First, we start the body. Okay. So here you need to only draw the hatchet portion. Okay. So in order to draw the hatchet portion, so I will start from this point. So what is the height of this? It is given 185, right? 185
Yes,
height.
sir.
This will be 70. So diameter is 70 means the half of this is 35. This is 35, downward 10 mm. Okay. So here I don't know this length exactly. Okay, just extend this. Extend this. So this will be 50. So diametrical difference is 20. That means one side will be have 20, 10 mm. So so year to year you take 25 mm. From here you take 10 mm. From this point you down draw a line downward 40 mm. You they given the dimension. This line you just extend it. Okay. So here again, this dimension will be how much? This one will be 140 mm. Okay, diameter. So you have to take 70. From 70, it will be 20. Okay. So then this point up to here will be, this is 100 is given. 140 minus 100 is 40. So on either side 20 mm. Ear to ear distance is 20 mm. Okay. So let's start the drawing. Okay, I will use revolve protrusion command. You will be having is a revolve protrusion option. Can you see this revolve protrusion? When the object is having axis symmetry, you have to use revolve protrusion command. Okay, so select revolve protrusion, select the plane. Okay, so here I want to see what are the tools I am using. So for that, you go to view. Uh, you go to tools and switch on the edge bar. Okay, so that you can see what are the component or what are the command you used in this tree. Okay, so I selected the axis revolve protrusion. Then will what is the height of this one? Height will be 185 mm, right?
185, sir.
185 at 90. Okay, so this will be 25 at 0, one line, another line will be 35. So you
Yes, sir.
already taken 25, so remaining will be 10 mm at 0. So from that you draw a downward line of 40 mm at minus 90. Okay, so then from this point 25 mm line, you just extend this line. I don't know the dimension. Again from this point it is, so 140 is the diameter, you take 70 mm at 0. Okay, so then upward will be 20 mm, right? 20 mm at 90. So then again it will be 20 mm at 180. Okay, so whatever you know, you create that profile. So then see here, I drawn this line I drawn. So then I taken 25 mm line and plus 10 mm line. From the edge you taken 40 downward, then you extended this downward. Okay, so then so what we can do here, I taken 70 mm here, 20 mm here and 20 mm here. So from here to here you need to join this line. Here you see, so this is say 66 mm diameter. So you already taken this 70 mm diameter, right? So diametrical difference you see from this point. If you take this point, so this will be 70 minus 66 diametrical difference. So radial difference, diametrical difference will be 4. Radial difference will be 2 mm. You draw 2 mm line at 180 degree, and from that edge you just join to here downward. Okay, understand?
Sir.
So here draw 2 mm line, 2 at 180 degree. From that 2 mm point you join to here. Is it clear?
Yes, sir.
Okay, so I drawn 2 mm line towards the left side. From because they given here, you see, you know this dimension from here to here it is 35. From this dimension from here to here, you know it is 33. So 35 minus 33 is 2 mm. You draw 2 mm, and from here you join to here this point. It will be 20 mm. So because they given this diameter is 100 mm, 140 minus 100 is 40 diametrical difference. Radial difference will be 20. You taken 20 mm from this side. Okay. Is it clear?
Yes,
Is
sir.
it clear?
Sir, it is clear.
Then what I will do, see here, this line is parallel to this line, right? These two lines are parallel to each other, right? Yes or no?
Yes, sir.
Yes, sir.
So I will offset this line for the thickness is given 10 mm. I offset this line for 10 mm. Okay. So you see. So select this line. Okay. Use offset command. Here you see offset you have. Can you see the command? Select offset. So I need to do single offset. I want to offset only this line for a distance of 10 mm. Select distance 10 mm or manually you enter. So then say right. Okay, right symbol is there now. Just you click that. Okay, it will ask whether you have to offset towards left or right. You click on the left side. Okay, so then what you will do? Trim unwanted line. I want this line till it will touches this offset line. So from other after that I don't want. I will trim this line. Again I will trim this line. Is it clear?
Yes, sir.
Okay. So then what else you required we'll see. So I get this point, this intersection of offset line and this point I will get. What you will do, you just extend this line up to here. So this is 3 mm point is given. So you from here you take 3 mm and you draw up to this will be 50 mm, 100 mm they given. So you draw 3 mm height and 50 mm line. So from here, so I will delete this line. I not required. This line is not required, and I don't want this also. I want to create only hatched portion. Okay. So from this end, you have to make sure that you are selecting the end points. Otherwise, you will get connectivity problem while getting a return. So 3 mm line you draw, 3 mm at 90. So then you take 50 mm at 0. Okay. So then downward you draw the line. Trim unwanted line. I don't want this line. I don't want this line also. I don't want this line also. You see here this triangle. So only this portion you have to retain. The bottom line also you can trim. Okay. So then here you need to extend this line. So use extend to next command. You see extend to next command. It will be below trim. Okay. So trim and extend to next it will come. Use extend to next command. So extend this inclined line what you are offsetted till it will coincide with this bottom line. Okay. So then you trim this point also. You can trim this also. And here in drawing you see they given radius here. It is not a flat edge. You will be having a radius. You give fillet between these two lines. Say 6 mm fillet. Here also you will give fillet. Okay. Of say 2 mm small fillet. That is not given. It is up to your choice. Select fillet. Fillet between these two lines they given in the drawing. Okay. 8 mm fillet you give. Is it clear? So we, in order to create this profile, we are doing all this circus. Okay, so that you will achieve. Here also, a small fillet is given. It is optional. So whatever the distance you want, you can select. Anyhow, you taken only 2 mm line. It should not be more than 2 mm. Okay, you give 2 mm exactly, or you can give 1.5 mm. So 2 mm. You give. See here, it is going. Just give a small fillet of 1.5 mm you give. Okay. So here also you need to give fillet. This one. Here you see in the diagram, if you see the given fillet, small fillet, even if you not do in the exam also, these fillets is negligible. So they will not going to cut the mass, but whatever the dimension is given, this fillet you have to give. Even you not give these fillet, these two fillet, it is okay. But you have to do this fillet, okay, as they given in the dimension. So I will select these two line and I will give 1.5 mm fillet. Okay. So is it clear? Is it over? Yeah, if you have doubt at any point, if you have doubt of error, you can zoom and see. So this is what the profile is required. See, we do all these circles to create this profile. Is it clear?
Yes, sir.
So I will not going to repeat because you will get a recorded video of this. So if you want to create, you go through this video and practice parallelly, so that only you will learn. Okay, what I did initially, I draw a 185 mm line, then I draw 25 mm line, and then 10 more mm line. Then I draw this 40 mm downward, and then I extend for unknown distance. Okay, I stop this here. Then I take on from this point, from here to here, I draw 70 mm, then 20 mm here, then again 20 mm here. After that, what I did, I take 2 mm distance here, 2 mm line here. From this end of the 2 mm line, I connected to this point. Okay, then I do round for this one and this one, and then so I offset this line to here. Okay, so 10 mm offset I did, and I so this line and this line will be intersecting. So I will trim the unwanted line. Whatever the extra extension of the line is, then I will trim, and the below the line also and above this line also you will trim. So then what I did, I take 3 mm distance, then I draw 50 mm and I draw line downward, then I will trim this unwanted lines. Okay. So you need to retain only this arched portion. See in your drawing, so what I retain is only this arched portion. Okay. So then for every revolved protrusion, you must have axis of rotation. Select axis of rotation, give this as axis of rotation. Return. So if there is no error in your drawing, you will return will be come. If you have any error, so this is again, if you want to go to profile page, you click on this, you will go to profile page. Suppose any of these two lines are not joined, means you have to use connect command, and then you have to join end of this two. You might have a problems comes in wherever you give fillet and all, you need to join end of the curve and end of the line. As I carefully done this line, so no error is coming. Okay, you also have to do carefully by referring all the end points and all, then you give return. So after that you give 360-degree, so then finish, so you will get a required profile. Is it clear?
Yes, sir.
Okay, then you keep it in dimetry. Okay, so then you save it in dimetry before you saving. Okay, keep it in dimetry. Here you see named views option will be there. Okay, in that all the drawing you have to keep it in dimetry and save. Otherwise, there will be problem when you are doing assembly. Okay, so this will be body of the screw jaw. Is it clear? Any doubts? So if you see, if you center button of the mouse, if you hold and rotate, you can see this. So it will be look like a edges, but it is circular only. You can see it is circular only. Okay. So keep it in dimetry, fit to the screen, then you save. Save this part because it is required when you are doing the assembly. I will save in desktop itself. Okay, desktop, I will create a new folder. So with my name. In that folder, I will create one more folder with assembly name screw jaw. Again, in this, I will save it as a body or part one. You can save it as part one. Is it clear?
Yes, sir.
Okay. Shall we move on to the second part?
Okay, sir.
So you need to practice this. Okay. If you are install this software, you recorded video you will get available or in the evening you might get it available. You watch those video parallelly practice. Okay. If you have any issue with that, you can call me. Okay.
Okay, sir.
If you video call or whatever you do, I will explain how to do and all. So you need to practice parallelly by referring to video. Is it clear?
Yes, sir.
Okay. So we'll move on to the second part. As I saved, I will open new page. So you have to create a part drawing. You have to select third one, normal dot part, PAR. If you click that, you will get a part drawing sheet. If you click this DFT, you will get 2D sheet, drafting sheet, what you used to use in your first year uh, engineering drawing. For part drawing, third one you need to select. Okay. So then okay. So we'll see the second part, what it is. See, this is the second part. Okay. So here also this is, you see the top view, you see it is a circular in shape. It is having axis symmetry, isn't it? So it is circular in shape and it is having axis symmetry. You see this. You see, this is the second part. This one. So this is second part. It will have axis symmetry. Okay.
Okay, sir.
So when you have axis symmetry, you have to use revolved protrusion. Here, what I need to do is I need to create only hatched portion. I need to create this profile. Okay, whatever inside it is hollow part, so that you need not to create this portion. To create only hatched portion. How to create? I start with this point. Okay, so you see here this line in the top view they given. Okay, internally you have see square thread. You will be having square thread of 38 mm diameter and 7 mm pitch. Thread pitch will be 7 mm. So this distance will be diameter will be 38. So the radius or radial distance will be how much? 38 divided by 2. It is 19 mm. So this is 19 mm. Draw 19 mm. From here to here it is 6 mm as it is given 50 mm. Okay. So you already taken 90 mm means this will be 19 25 minus 90, it will be 6 mm. Okay. Draw 19 mm line and then 6 mm line. So what is this distance? So this distance total will be 45. And so these two will be 10 10. The remaining will be 25. Draw 25. So this distance will be how much? So here you see 90 minus 50. The diametrical difference will be 40. So on one side it will be 20 mm. 20 mm. Then you draw 20 mm, 10 mm this one. This is also 20 mm. Then 10 mm. Then this will be 6 mm. So you need to create this profile. Okay. So I will select a revolved protrusion. Select the front plane. Okay. You need to select a suitable plane. Select front plane. I'll create from here. So draw 19 mm at 0, then 6 mm at 0, then 25 mm at 90, then 20 mm at 0, then 10 mm at 90, then 20 mm at 180, then 10 mm at 90, then again 6 mm at 180. So then from this 6 mm you have to draw downward line, so that I required only this profile. Only this profile we require. So this will be cutted portion. See, make sure this will be 6 mm. So you see 6 mm line. Okay, this is 20 mm. So after creating this, see how I created. Sorry. So here 19 mm line I drawn from here to here 6 mm. This will be 25 mm line. This will be 20 mm line, 10 mm. So then this will be 20 mm again, then 10 mm, then 6 mm, then you close this. This is how I created. So this it has to be 10 mm. Okay. Circle you have to draw 10 mm. So here it will be having a fillet option. So what I will do is I will use fillet between these two line, this line and this line. So I use 5 mm fillet. Again between these two also 5 mm fillet use. Or else one more option you will be having. So from the midpoint of this, take 5 mm line at minus 90. Sorry. 5 mm at 180. Okay. So then draw a circle of 10 mm anywhere else. 10 mm. So then move this circle from the center point and place this center at this point. Okay, then you can trim unwanted lines. You can trim this line, this line, this line, and this line, as well as this line, this line. Okay, is it clear? What I did is, so from the midpoint of this line, I taken 5 mm line. Okay, so I draw a 10 mm circle and you move from the mid of the circle and place it here. Okay, see, move from the midpoint of the circle and place it here. So then you trim unwanted line. Like this. Okay, so I have a doubt that the end of the curve and end of the line is not joined. You try to join. See, this is the end of the curve. This is end of the line. So if it is coming like this, that means it is already joined. No problem. Okay, so then I also give fillet to this stage and this one. I give fillet of 5 mm. So here also you need to give fillet between these two, this line and this line. 5 mm fillet you have to give. Is it clear? This is what the profile is required. Is it clear? Okay. So then select the axis of rotation, select the axis, then say return. So if you don't have error, return will function properly. If you have error, so then you have to rectify the error. Say if you have overlapping line like this, so I drawn say unknowingly I drawn a short line like this. So two lines are overlap. Here you have one line, here you have one line. Like this, if this sort of error is there, if you try to go return, so it will not come. Say more than two elements are joined at a single interaction. So see here, this is the interaction. More than two elements are joined. So sometime it will give overlapping. If it is a problem like this, you try to delete whatever the pink portion is there. You delete that for time being. See, I deleted. So even after deleting, I will come to know one more edge is there. That's why it is not functioning properly. So then what you have to do? Undo, then delete this line. So if that sort of error is not there, return will be work like this. If that sort of error overlapping line is there, it will not work. Okay. And the two lines are not connected means it will not work. two elements are not connected means it will not work. Okay. So then return. So it is also 360 axis 360. It has to give finish. So this is what the profile required profile. Okay. So one more thing you have to do. You see in the drawing that they given like this. Okay. If you give like this, so it is nothing but thread. If you have a thin line, just side of the thick line in the hollow section, that is nothing but this is thread. And also you see in the top view, sometime only one view will be given. If they give like this, you have to understand it is the internal thread. It is having internal thread. In top view, they will give two circle. One circle will be complete circle. Another circle will be see 80% circle will be given. The partial circle is given means it is having internal thread. Okay, you have to create an internal thread of 38 mm. So for that, what you have to do? So if it is having a normal hole, so then you have to create this profile. It is not having normal hole. So for that, instead of creating this hollow section in the this one, so what you have to do? See, this will cancel. I will edit this profile. So I want to change the edit definition means you given 360 revolve protraction. Suppose if you want only 180 revolve protrusion, then you have to go for edit definition. When you are altering third dimension, for altering two-dimensional profile you run, you have to go for edit profile by right-clicking the protrusion. This is what revolve protrusion you already done. Right-click this revolve protrusion. Go to edit profile. In the edit profile, what you have to do? I don't want this hollow section. I want complete solid body because it is not a normal wall. It is a threaded wall. So what you have to do? You just delete this line. Okay. Uh, delete this line. So then extend this line. Like this. You have to create profile like this. Okay. If it is having normal wall, okay, you can draw only hatched portion. It is a threaded wall. For that a solid body has to create it. Then you have to create an internal thread. Then you select axis of rotation already selected, says and return. So create this. Okay, a solid body will be created. In order to create a threaded wall, what you have to select? This is normal cutout. For creating a simple wall, you already used in this previous uh, plumber block assembly part drawing. Used this cutout, normal cutout. If you want to have special cutout like threaded walls, then counter bore, counter sink, what you have to use? This will be a wall option you have to use. Cutout used for regular cutout. Wall option will be for special wall. So here select wall option. Okay. So I want to create wall on this surface, right? So select a top surface. Then you have to define the wall. In order to define the wall, you have to click here, wall option. Okay. Are you able to follow the cursor?
Yes, sir.
Okay, click here. So what type of wall you want? Threaded wall I want. Okay, diameter of the thread. How much diameter? 38 diameter. So here you see the given 38 diameter. But square thread will be. This indicates square thread 38 diameter 7 inches. The pitch is 7. Okay, so 38. So here you have to select 38 into 7. Is there option is there? 38 into 7. You have to select. Then to wall extent. So you required this thread through the entire solid. So that's why you have to select wall extent. Okay. Wall extent means complete you will get. Finite extent means only Up to partial depth, you will get the thread. Yeah, in this case, you required whole extent, select whole extent, then OK, place that it in center, then return. Show the direction downward, finish. You see, the threads will be shown in a green color surface. Okay, so even you can see if you go to view, format, if you go to format and view, here you will be having texture command. If you click on the texture in rendering option, if you click texture, okay, for just for your understanding purpose, I am showing. Okay, you can see format, view, texture. Okay, so it's not working. Last class I shown, I think. So thread was visible when I select the texture. So anyhow, leave it that. So if we have a green color on the internal surface or external surface, that means that is a thread. Is it clear? The second one is over. You save this file. Before saving, every time you have to so keep it in diametric view. Go to named view, keep it in diametric view, and then you have to save so that it will be helpful when you are doing assembly. Save it as part 2 only. Save. I already defined the path, then you just save. Is it clear?
Yes, sir.
So then we'll move on to the third part. Select new file. So part drawing, third object. Okay. So third one will be this. Okay, what is the third part? A screw spindle. Okay, so how to draw this screw spindle? You see, this is a revolved protrusion. Okay, you will be, this object is also having axis symmetry. Here it is showing in horizontal position, so you can do vertically or horizontally, no problem. When you are doing assembly, you can use whatever position you want, as the assembly will be having vertical alignment only. Okay, so that's why I will create it vertically only. So by selecting the print plane, now you need to create only this outer boundary. I already told you, if you have two line visible edge, below that you will be having a thinner line. If it is there, it is nothing but it is a thread. Okay, it is external thread. Threads are there in external surface. Here you have internal thread, you seen here. This is external thread. You have to learn the how to read the drawing. It is very important, because same drawing you can do it in UG, or you can do it in CATIA, or you can do it in higher version of software. But reading of the drawing is similar. Whatever the software keep on changing. Whatever the software will come, reading of the drawing is same. Okay, you see below or above the visible line, you have a thinner line that indicates edge. You can, and also you can see in the top you have a visible circle. Above that you have a partial circle that indicate thread. So here also you will be having visible line with thin line. Okay, that indicate thread. Here also thread is having 38 mm diameter and 7 mm pitch, because it has to go inside this. Okay, it has to be same, so that only it will engage. Okay, so what I have to do, I have to create this outer boundary. Starting from this point, I will start from this point. I vertically I will create. In the drawing, it is shown in horizontal direction. I will create vertically. For your understanding purpose, I can rotate this like this, so that you can read it properly. So from this end, I will start. Okay. So what will be the this line? What is this line? Can you tell me?
Sir, 83. 38, sir.
38. Half of the 38 will be 19.
19.
19 mm. From here to here, what distance?
Sir,
From here to here. So total is 240. 240 minus 83. So here, from here to here, 83 distance is given. 240 minus 83 is how much? 157, huh? Is it right? 157. So 19 mm at 0, 157. So then you draw this line. What is this? What is this diameter? Is it given anywhere? This is 45. You have chamfer. So we'll start doing, then we will get the dimension. Okay, select the revolved protrusion, select the front plane. So I will start from here. So this will be say 19 at how much? 0 angle. Then so 157, right? 240 minus 83, how much? You can
157, sir.
240 minus 83. You can in the dimension box also you can do like this. 240 minus 83. Enter. So it will take 157. Then the angle will be 90. Okay. So then fit. I don't know this length. For time being, you left it like that only. I don't know this length because here they given from this point, so they given chamfer 10 mm at 45 degree. This has to be 45 degree. Setback distance in chamfer we call this as setback distance. Setback. Okay. It will form a right angle triangle, right? So
Yes, sir.
adjacent and opposite side will be 10 mm, 10 mm. That is setback distance. Setback will be 10 mm, angle will be 45. Okay. So from this point we'll start. Okay, again. So length will be 240. What about this direction? This length will be say here 22 mm diameter is given. This will be half of that 11 mm. So 240 at 90, 11 at 0, then downward direction you given 13 mm downward, and this distance. Okay, we don't know this distance as the given setback 10 mm. So what you have to do? Here they given 65 mm. You already taken 11 mm. So 65 divided by 2 is 32.5, right? 32.5 minus 11 will be 21.5, this dimension. Okay. So you draw 65 minus 22. How much? 43. 43 or half of the 43 will be 21.5. And if you neglect 10 mm here, 21.5 minus 10, it will be 11.5 here. 11.5, you draw a line here 10 mm and below also 10 mm. You just join these two lines. Again, you draw this profile. So this length will be how much? So from here to here, it will be 10 mm. Let's start doing that. You will understand. Okay. So from this point, so you have to select the end point of this. So, okay. So 240 at 90. Select 240 at 90. This will be, say 22 is the diameter at the top. So radial distance will be 11 at 0. 11 at 0. So this will be 11 at 0. This will be 13 mm downward. 13 mm at minus 90. So then what about this distance? So this will be 65 minus 22. It will be 43. Okay, 43, half of that 43 will be. Okay, so if you minus 65 minus 22, 43. So on one side it will be 21.5. So as the given setback distance 10 mm, this one. So chamfer setback will be 10 mm. Okay. So this will be 21.5 minus 10, it will be 11.5. Okay. So this will be 11.5. So you draw 11.5 line at 0. Again you draw 10 mm at 0. Again you draw 10 mm at minus 90. So then you join these two lines. Okay, but use zoom option. Join like this. Then you can trim this unwanted. This is setback length 10 mm. You can delete this. Okay. So then again, this distance will be how much? Here you see, this distance will be, you already taken line up to this point. This distance will be 10 mm as the given setback distance, 10 mm. Okay, so whatever length you will have from here to here, it will be total length minus 10. Okay, what I will do? So this length will be 60, right? You can see 60 minus 10 will be, as I move the cursor here, the vertical length will be 60. What I have to do 50 mm. These are derived dimension. Okay, then so I will get up to here. Then you have to take 10 mm downward, 10 mm left side. Then you can join these two lines. Okay, 10 mm downward at minus 90. Again 10 mm left side, 10 mm at 180. Okay, then you have to join these 2 points. Okay, so then trim this unwanted lines. So then join these two lines. Okay, this is what the required profile. So then after drawing this, you use revolve protrusion. This is what the outer boundary is. So what I do, so I will explain one more time. You see how I proceed the drawing. From this point, you draw 19 mm as the given diameter of the thread is 38, 19 mm at 0. This length will be, so as the given, it total is 240, 240 minus 83. It is 157. I don't know this length. I stopped here only. Then I taken 240 mm length. Then I know this diameter is 22. I taken half of that 11. Then downward 13 mm. Then this distance I know. So it is 65. 65 minus 22 is 43. 43, half of that one is 21.5. Again you neglect setback distance of 10 mm. So 11.5. So then plus 10 plus 10 downward. So then you join these two lines. So I don't know this distance. What I did, I calculate, you draw the horizontal line here and you draw this line till it intersect here and find out what is the length. It will be 60 from here to here. So minus 10 you cut and you draw 50 mm. Again you draw 10 mm downward, 10 mm left side. Then you join these two lines. Then you trim this setback length. Then you join these two lines. This is how I create this profile. So now I will do revolve protrusion. Select the axis this line. Do revolve protrusion. Say return. So profile not closed. Here it is showing profile not closed. So here it is having error. So what I have to do, wherever it is showing pink color, I try to join, connect these 2 points. End of this line and end of this line. So earlier it is not connected. That's why it is shown not show any new dialog box. Then you try to return again profile not closed. So where it is showing profile not closed is at this point. Maybe the joining between these two lines it is not closed. What I will do, I zoom to that particular area, then connect the two line. Connect end of this line and end of this line. So you have to rectify this error and you have to resolve this. Then only your return will work. So then give 360 rotation. Fit. Okay, like this is what the profile is required. Finish the outer profile. Is it clear? Is it clear?
Yes, sir.
Any doubts you have?
No, sir.
What I am explaining is you are understanding?
Yes, sir.
ಅರ್ಥ ಆಗ್ತಿದೆಯಾ bro?
ಅರ್ಥ ಆಗ್ತಾ ಇದೆ ಸರ್.
Okay, you do practice parallelly by viewing, seeing the videos of recording. Okay, then only you will able to do. Okay.
Okay. Okay, sir.
So then what else is in this part? You see, you left with this one. What is this? External thread you have to create. So as we know, this length is 157. So I required external thread up to 154. This 3 mm thread is not there. How you know? See, here hidden line is given up to this line, this length only. This 3 mm you don't have thread. Okay, thread will be there up to 154 mm. Okay, and also you have to create a counter bore wall here. So screw will come here. Okay, in order to that you have to create a counter bore wall with thread. Here M12 thread will be there. Here also you see you will be having two lines, visible line, and also you will be having, see, hidden small line. So that indicates a thread. Internal thread you have to create. Then you will be having knurling. So knurling option is not there in your, here also you will be having knurling in this part also for gripping purpose when you are rotating. So for gripping in the hand, this knurling is given in Tommy bar as well as this one. So knurling option will be not there. You just no need to worry about this knurling option. You need to create external thread and screw hole, and as well as this hole. This hole is 12 mm through. This wall will be in all four direction. Here it will be there, here it will be there, opposite end will be there, here it will be there. What you have to do, you have to create the wall. So then you extend. You see here. So here it is showing in only one direction you have. So you can give one wall. So depending upon your drawing sheet. Okay, here also in your drawing sheet also you have one wall. Suppose in your drawing sheet, if they given like this, here also like this cutout is given, means that indicates another. In some time will be have four walls on four perpendicular direction. In some time it will be having one wall throughout. Okay, for keeping this Tommy bar end and to rotate this. Okay, I will create this wall of 12 mm. It will be 35 mm above this line. Okay, above this point, 35 mm. So what I will do, select this. You select center plane, front plane for creating a wall. It is normal wall, just use cutout option. Select this plane, center plane, front plane. So this wall will be at a distance of, from this midpoint. So you see, I am taking this line as reference. From the midpoint of this line, draw 35 mm. You see in your drawing, they given 35 mm distance. So here you see this wall is 35 mm distance from this reference line. Okay, from you say from the midpoint of this line, you draw 35 mm and then you place a 12 mm wall here. So draw a circle of 12 mm from this center. 12 mm. Okay, then you construction line you can delete, then do return. So you have to create wall on either end. So extended symmetric extent use. So both end you extend this wall. Finish. From the center plane you created a wall, extend on either side. We'll get this. Okay. After that, what you required, you keep it in diametric. I want to create external thread. So here, so in order to create internal thread, you have to select a hole option and then you have to select a surface. For external thread, just beside the wall option, you have downward arrow. You see, in that you will be having thread option. This is used for external thread. Select this. So straight thread I want. Okay, it will ask, click on the cylinder to thread. I want to cylinder this thread. This cylinder I need to thread, right? Select this. Okay. Click on the end of the cylinder from which thread will be offset. I want to thread has to come from this end. I will select this. Before that, I think whether you have chamfer option, so forget about that. Even if you not do, that is also okay. Okay, I want to offset from this end. Okay, then it will ask whether you need to you need thread for the full extent of cylinder. I no need to get full extent here. Yeah, I have to get for up to 154 mm. Total will be 157 this cylinder. Minus 3. I want 154 mm thread. So for that, you have to select a finite value. A finite value will be 154. 154 up to 154 I want. So this is again 38 into 7 I want. Okay, then you do finish option, cancel. So it is taking for full extent. Okay, so it will be software error. No need to worry. If you even it take full extent, you no need to worry about this. Is it clear?
ಸರ್ ಸರ್ ಟಾಪ್ ಸೈಡ್ ಡ್ರಿಲ್ ಮಾಡ್ಬೇಕಲ್ಲ ಸರ್?
This one screw hole. Okay, this is what you are asking, right?
ಎಸ್ ಸರ್, ಎಸ್ ಸರ್.
I will do that. So go to this. I need to create, keep it in diametry, fit option. So here hole you have to select hole on this surface, right? So define this. What type of hole you want? Countersink, right? Like this. Okay, what is the diameter of the hole? So M12 is the diameter. This so you will be having screw. Yeah, this is also M12. Okay, whatever screw diameter is there, this screw will come and fit here. Okay, this is also this thread will be up to the whole extent will be 35 mm. Thread will be finite extent. It will be, you see the thread will be up to 30 mm only. Can you able to see in the drawing?
ಎಸ್
The
ಸರ್, ಎಸ್
hidden
ಸರ್.
line, sir, the thin line will be up to only 30 mm. Up to 30 mm extent thread will be there. Whole depth will be 35 mm. M12. You select and diameter will be 12. Countersink diameter, countersink angle. It will be generally you select 82 is this one 82. Then thread to finite extent you want thread. Say thread will be up to 30 mm. Whole depth will be here. You have to give here. You select this. Okay, you want a finite extent whole depth will be 35 mm. V bottom you required. Here you see you require V bottom. V bottom. V bottom. The whole depth will be 35 mm. Thread will be up to finite extent 30 mm. This will be 82 mm. You give. Okay. So this is important. The diameter is 12 mm. Countersink diameter. No need to give this. Let's see. So this countersink angle will be 82 mm. So thread will be. So what type of thread you want? So they might given here M12 thread. So thread will be M12. You have to select M12. Here you see in the option you will get M12. You search, you will get M12. Here you see M12. You have to select M12. Okay, then so finite extent thread 30 mm. Whole depth will be 35 mm. Okay, then okay. Countersink diameter must be greater than the whole diameter. Okay. Countersink diameter. So you just give 14 mm countersink diameter. Diameter of the wall will be 12 mm as they given in the drawing. 12 mm. Okay, this one. So this is 12 mm. This counters this diameter. It is not given. Let's take 2 mm more than that. So it will be 14. Say OK and placed here. So then return. So show the downward direction. Finish. Is it clear? You will get like this.
Okay, sir.
You can see V bottom also. You can see. See this is V bottom. You can see here. Okay, you keep it in diametric, or you can keep it in front view. You go for wireframe model. You see this countersink you achieved. Can see. Okay, is it clear?
Yes, sir.
Keep it in diametry. Is there anything left in this part? So this is over. This one is also over. External thread is also over. Only that much is required. So we will save this part as file. Save as part 3.
Part 3.
Okay. So remaining part, I think time is over. Remaining part, we'll take it in the next class. I will end this session for today. Okay, you practice these 3 part along with plumber block part what we discussed in last class. Will you practice?
Okay, sir.
If you
Yes,
not
sir.
practice, I am assuring that if you not practice, you definitely are going to fail. Okay, it
Okay, sir.
required lot of practice because assembly has to do in 1.5 hour time in exam. You need lot of practice. You have to practice in such a way that dimension should be remember. In exam, you need not to analyze all this dimension. Okay, if you practice, once you see the drawing, immediately you can understand what is the dimension I have to you need to give. Okay, analyzing and doing it will take lot of time. You have to do it in 1.5 hour. So if you practice every assembly 4 or 5 times, then only you can do it in 1.5 hour. Okay, hope we will all practice. I will end this session for today. Okay, thank you for joining. Have a good day. We'll see you tomorrow for MCW class.
Thank you, sir.
Okay.